for Matthew? So everybody say hello to Matthew.
Hi, Matthew.
Hi, Matthew.
There we go. And don't say bad things about him. Wait till we... Wait.
So short.
Okay.
It's like taller than me.
Solving differential equations analytically. So first of all, in order to solve a differential equation, everybody with me?
Yes.
In order to solve a differential equation, what that means is if you are given the derivative, then they want you to find the original. Okay? Solving a differential equation means you're given a derivative and you want to find the original. Well, we've done this. I mean, if you're given a derivative, how do you find the original? You integrate, right? So look at my first example. It says find the general solution. The only thing that's going to look a little different at first is the way they ask the question. Because maybe in the past they haven't said find the general solution. They would have said find f of x or find y. Okay? So if I want to find the general solution, if the derivative is 2x, you tell me, what would the original be? X squared, but what do I need at the end? Plus c. Okay, so notice when it says general solution, that means you don't know what c is. So all you can do is write plus c. If they said find the particular solution, then that would mean they want you to actually find out what the c is. But if they want you to find the c, that means what? They're going to have to give you some ordered pair that you can plug in and find the plus c, right? Okay. But, and here comes the different part. What about a differential equation, meaning a derivative that's in implicit form? What if they give you the derivative dy dx equals 2xy? Because we've never integrated something like this, right? We've never integrated 2xy. We've integrated 2x, but not 2xy. That's what today is about. All right? So, well, and I hear someone say solve for y. But if you solve for y, it's going to be in terms of a derivative. So that's not really going to help. All right, so that's when we, number one, separate the variables. You called it. Is separate AR, separate, is that right? Yes. Separate the variables. And by the way, what we're learning today tends to be a free response topic, and it's usually between 4 and 6 points of the 9. This one solving kind of thing. It's between 4 and 6 points of the 9. So it's a kind of a big deal free response topic. You separate the variables, and the thing about it is, if you don't get them separated correctly, you're not eligible for any of those 4 to 6 points. So in order to even enter the problem, you have to know how to separate correctly. Okay, so first you separate the variables. So how about we do a problem as we're filling in our step-by-step. So look down at example 1. Find the particular solution to the differential equation. So when you separate, that means not only are you separating the x's and y's, but you're also separating the dy and the dx. And in the past, we've never thought of that as being something different, but it's okay to separate it just like two separate terms. So what that means is I need to move the y over to this side with the dy, and at the same time, I need to move the dx over to this side with the x's. Well, now you know. Because it's kind of like on a need-to-know basis. You didn't need to know until now. All right, so how am I going to move the y to that side? Please don't say subtract it. Divide. So on the other side, I'm going to write 1 over y dy. Why did I write 1 over y dy instead of dy over y? Because doesn't that look like something that you could integrate? Okay. And then on the right side, I've got the 2x that was there and then the dx. So does that make sense? I have all the y's, including the dy on one side, all the x's, including the dx on the other side. Okay? That's what we mean by separate. And by the way, I want to put a little qualifier on my separate. You can only separate by multiplication or division. You can only multiply both sides or divide both sides in order to separate correctly. You cannot add to both sides or subtract from both sides, and I'll show you why that's the case in a minute when we get one. Okay? Step 2, well, once they're separated, then you can integrate both sides. So step 2 is integrate both sides. That's the whole reason we separated, because if it's only one variable, then I can integrate both sides. So I'm going to integrate both sides. Okay, what's the integral of 1 over y? Natural log of the absolute value of y plus c equals, what's the integral of 2x? X squared. Okay, now wait a minute. If I say plus c, do those c's cancel each other out? They're not necessarily the same c. Does that make sense? So how about we do this? Could I, if I wanted to, could I like move this c over here and combine it with the other c and just think of it as one big C? So I think what we'll do is, when we integrate both sides from now on and forever, instead of putting plus c on both sides, we'll just only put it on the right side and know that, okay, it just counts as the c's combined. Everybody with me? It's perfectly fine to do that. Okay? Step 3, once you've integrated both sides, solve for y. Because the whole point was to find the original function, right? Find y. Oh, no. How am I supposed to solve this for y? The only way to get something out of a log is to change it into exponential. Now, can I show you something that is kind of icky looking, but it makes it easy to think about? Here's what I hear a lot of people say. Instead of thinking of it as changing it to exponential, here's what I hear them say: E it up. In other words, think of it as letting the base, because whatever you do to one side, you can do the other side, correct? Would you agree? So what if I make the base of one side e? That's fine as long as I make the base of the other side e. Is everybody with me? If I think of it that way? Because now on the left side, don't the e and the natural log cancel? And all I have is y. And by the way, now that the y is no longer in the natural log, I don't need the absolute value anymore, because I only needed it when it was in a log. Is everybody with me? Everybody okay? On the right side, I have e to the x squared plus c. Notice that plus c is all in the exponent. It's not e to the x squared and then plus c out at the end. That's probably one of the most common mistakes I see, is that they put the plus c out at the end. But if you do this e it up thing, it's in the exponent. Everybody with me? Now, wait a minute. If I have, think about this. I'm going to go off to the side here just a minute. You don't need to write, just take it in. If I have, let's say, e squared times e to the third, if I want, I could add those exponents to be e to the fifth, right? Right? Okay, everybody with me? What if for some reason I have e to the fifth, and I don't know why, but what if it's easier for me if I think of it as e squared times e cubed? So it's okay to break it apart, right? Right? Okay, so think about this. Would you agree, don't write, just watch for a minute, would you agree that this e to the x squared plus c is the same as e to the x squared times e to the c? Because in order to combine them, wouldn't you add your exponents? And then wouldn't that become x squared plus c? Don't write, just take it in for a minute. Everybody with me? Okay, why would you want to do that? Because what is e? A constant. And if it's a constant raised to a constant, isn't that just like another big old constant? So really, if I want to, I can just think of e to the c as one big giant c. Not the same c, but a different c, right? So all of that to say, don't write yet, all of that to say, now pick up your pencil, all of that to say, anytime you have a plus c like this in the exponent, it's okay to think of it as a c down in front and then e to the x squared. because it's kind of like multiplying it by e to the c, which is a different constant. So it's just kind of like thinking of the whole thing being multiplied by a constant. Now, do you have to do that? No, but it'll make your life easier as we do some solving later on. Right now, you're kind of like, I don't know about this new math you're teaching us, but we're going to do it so many times, you're going to be like, oh, yeah, put the c in front. Not worried. You're going to be fine. Okay? Uh-huh.
The c's multiplying the x squared?
The c is being multiplied because this was kind of like e to the x squared times e to the c.
Oh, right.
And so this is like one big giant c multiplying by the e to the x squared. You don't have to show that step. That's the y. I like to show it kind of one time so you know why it's okay. But from now on, we'll just put it as a c out in front. Question?
Normally, why is it find the, or what does the phrasing mean in find the particular solution to the equation?
That means find, we're not done yet. It means find y without a c in it. Like actually find out what c is. We haven't gotten there yet. We're trying to solve for y. Does everybody agree right now we have solved for y? Yes. And now I need to go up to number 4 that says solve for c and substitute, meaning solve for c, find out what c is, and then substitute that into the equation. So how do I solve for c? Just like we always have. We use the ordered pair. Did they give us an ordered pair?
Yes.
Right here. So this says if x is 0, then y is 2. Right with me? If x is 0, then y is 2. So 2 equals c e to the 0. Do you now see why it's so nice to have that c out in front? Because what is e to the 0? 1. So what is c? C is 2. So we've solved for c, but the answer isn't what is c. The answer is what is y. So y is 2e to the x squared. That's the particular solution. If it had the c, it would be the general solution. Let me write that down. This is the particular solution. If they had asked for it, I would say this is the general solution. Okay, so the difference between general and particular is if you can find c or not.
So we wouldn't know what the original c was, like in the x squared plus c thing. Like we know what our new c is, but
Right, so this is the c that makes the equation. You could go back and find that, yeah, but that's not going to ever be an issue. Everybody with me? And this is one of those that at first you're like, oh my gosh, did a whole lot of steps. I feel like my processing still needs to catch up. But as soon as we do another one, you'll be like, oh, I should do the same thing every single time. This is not going to be a problem.
Are there ever going to be problems where you can't pull the C out to the front?
I'm glad you asked that.
Oh.
We're going to do some. It's no big deal. You just handle it wherever it is. Okay, look at example 2. Find the hardest part about these is knowing what they're asking you to do. Okay, notice it says find the equation of the curve. In that case, there's nothing to know. If I want the equation of the curve, doesn't that mean find the original curve? Notice they gave me a derivative. They gave me an ordered pair. I've got everything I need. All I need is a derivative and an ordered pair. Ready? Step 1, separate the variables. This is the crucial step. You got to get this one right. So if I'm going to separate the variables, I need to move the y over with the dy and then the dx to the other side. So on the left side, what do I have? Y dy. And on the right side, what do I have? 1 over x dx. Questions there? Everybody okay? Step 2, integrate both sides. Okay? Integrate both sides. So y squared over 2, and remember we don't need to write the plus c on both sides, we'll just write it over on the x side, equals what? Natural log, absolute value of x plus c. So step 1, separate. Step 2, integrate. Step 3, solve for y. So don't I just multiply by 2 and take the square root? Everybody with me? So y equals, now I'm going to multiply by 2 separately because I want to show you something. If I multiply by 2, it's 2 times the whole thing, right? So just watch for a second. So I could say 2 natural log of x plus 2c, but I want to show you something. Don't write. Isn't 2c just another constant? So yes, I'm multiplying by 2, but it's okay to just write it like that, because when I multiply c by 2, it's just another c. If it makes you feel better, I could say, hey, that's c1 and that's c2, but you don't have to. It's just another constant. If you want to write it as 2c because it bothers you too much to not to, then write it. That's fine. Is everybody with me? I'm just trying to save your steps. Everybody doing okay? Oh, sorry, this is still y squared, isn't it? And now I need to take the square root. So y equals square root of 2 natural log of x, absolute value of x, plus c. Notice the plus c is under the square root, right? Hey, on this one, could I just say the square root of that and leave the plus c, because it's kind of like saying the square root of c is just another c? No, because you can't take the square root of things being added separately. Like, for example, the square root of x squared plus 9 does not equal x plus 3. You can't take the square root of addition separately. Okay? Yes?
Would you want to make the x squared?
Oh, you can. It doesn't matter. I probably wouldn't worry about it. Now, what am I missing? I know I'm going to find c in a minute, but what am I missing? Whenever you take the square root, plus or minus. Okay. Now, here's a little hint. Plus or minus is kind of like saying, I'm going to give you a multiple choice answer. You pick the one you want. No, you need to tell them which one it is. Is it going to be a plus or is it going to be a minus? How do I know? Look at the point. Is y positive or negative? Y is negative. So which one do I want? The negative. So it's okay to just use the negative. You'll always know if it's plus or minus based on the point they give you, whether or not y is positive or negative. Is everybody with me? Okay, so I've solved for y. Last step is to find c. How do I do that? By plugging in my ordered pair. So negative 4 for y equals negative square root 2 natural log of 1 plus c. Hey, good news. What's the natural log of 1? 0. So really I have, hey, now that I have a negative on both sides, can I just say that 4 equals the square root of c? So what is c? Don't say 2. Isn't c 16? So did the directions say find c? No, they said find y. So y is negative square root of 2 natural log of absolute value of x plus 16. Now just to show you, you know how I said this is anywhere from 4 to 6 points? It used to always be 5 points. And when it was always 5 points, they would do it this way. 1 point for correctly separating. And if you didn't get that point, you're done. You get nothing of the 5. If you correctly separated, it would be 1 point for integrating the left side, and 1 point for integrating the right side correctly, and 1 point for putting the plus c on either side that you choose. So that 1 point is included with the integration of that side. So it's like one of those points you're going to lose if you don't have the plus c correctly placed. With me? And then it was 1 point for knowing to use the ordered pair to find c, not even using it correctly, but knowing to use it. And then 1 point for solving for y correctly. So in the old days, it was always 5. A lot of times now, well, on the BC exam, they're tending towards 4. On AB, it's probably still going to be worth 5 points. But you're going to see after doing the homework today, you're going to do this so many times, it's just going to become second nature. You're going to go through the solving. When you see these, you're going to be like, thank the Lord, easy 5 points on free response. It really is. Okay? Got the idea? Let's do this. I need to keep track of my 6 period time, 110. Yeah, perfect. Let's do this. We're going to come back and do this example 3 in a minute, but go to the homework page on 238 and look at number 4. Homework page, look at number 4. Everybody with me? Notice the directions say solve the initial value problem by separation of variables. So they're telling you, hey, do separation of variables. Okay. On number 4, I'm given a derivative. The reason I want us to look at this one is, do you think before I separate, I should distribute the x? Absolutely not, because as it is right now, could I separate only by multiplication or division? I could. But if I distributed the x, then I'd have to subtract from both sides. Do you see the difference? Okay, so number 4, if I separate, what am I going to have on the y side? 1 over y plus 1. Do you see how I'm dividing by the entire parenthesis, y plus 1, and moving it to the left side? dy. And if I multiply by dx, then on the other side, I just have x dx. The hardest part of that problem is knowing to separate correctly. Is everybody okay with that? All right, go ahead. Keep going. This is your homework. See if you can integrate both sides and solve for y and find your c and so on. Luckily, we know how to integrate u prime over u. Luckily, we learned our fancy E it up method.
Yes.
I tend to, as soon as I E it up, I tend to, on the next step, just go ahead and put that C out in front, without even having to think about it. Again, you don't have to. I just think it makes your life easier. Logan, what question do you have?
Where the over, I just messed up my integration.
The red was my integration.
I forgot to put it over 2.
Ah, yes. There's one step here that is calculus, that first integrating both sides, and all the rest is algebra, solving skills. How are we doing? Are you starting to see that you kind of do the same thing every time? Sometimes they turn into natural log and sometimes they don't. Okay? Everybody feeling good? Matthew, you feeling good? Reminds me of the old Zoom days. That's why some of the videos, if you've ever watched some of the videos that are from the old Zoom days, you can hear me talking to people, and you're like, is she talking to herself or her dogs or what? But that was in the Zoom. Question?
Does it matter if when you plug in the c at the end, if the c is in front or if it's still in the exponent?
Mm-mm. Mm-mm. As long as, here's the, well, let me back up. I might take that back. Wherever you solve for c, that's where you have to plug it in. So let's make it, I'm glad you said that. So like, for example, look right here. Here is where I solved for y, and then I solved for c. When I got c equals 5, you can't plug 5 back up into this c. You have to plug it into whatever equation you solved it from. I'm not sure if that's what you were asking.
Yeah.
Are we clear on that? As soon as you solve for C, that's where you have to plug it in. Okay?
Can your C have E's in it, like a determinant?
Oh, yeah.
Does it cancel? So
Yeah. It could be ugly. It could be terrible ugly. Because this is going to be let me back up. This is going to be a free response more than likely. If it's a multiple choice, they usually work out kind of pretty so that it's easy to notice a multiple choice answer. And I'll show you both when we start practicing. Okay. Before we go back to that last example, I want us to look at number 5. Number 5. The whole reason I took you to number 4 first is because look at number 5. Now, don't write. I want to show you something. On number 5, look here. Notice this has both a y and an x, right? And there's subtraction. Even if you wanted to, which hopefully you wouldn't, even if you wanted to, you don't want to say dy plus y sine of x for lots of reasons, because if that's the case, that y sine of x is not a part of the dy that you would be integrating. That's why you don't ever want to separate by addition and subtraction, only by multiplication and division, which means, what are you going to have to do on this one before you can separate? Yeah, you're going to have to factor out that sine of x. So think of it as dy dx equals sine of x times 1 minus y. Now, I mean, we're here, we might as well finish it, right? Now you can separate it. Now you can separate. This is one that has a very common mistake. I wonder who I'm going to get. Of the 9 of you, I bet I get 5 of you.
No way.
Okay.
You don't think so?
And by 5, I mean at least 5.
At least.
It's the integration where I'm going to get you. I think y'all are going to be good on the negative cosine. That's not the problem. It's the left side. Okay.
you
Okay.
gave us 2 hints where we figured it out before you. I didn't even need that.
Well, I haven't given you any hint yet. It's the left side that I think is going to be the mistake. You know what it's going to be, Christopher? Don't say it.
Yeah.
I'm not gonna attempt it.
You know what I'm thinking. So before you solve, see if we agree on the integration. Do we agree on the integration?
No. No.
What's wrong?
It's negative.
One in front of the natural one.
Okay, tell the truth. How many of you noticed that there needs to be a negative? Tell the truth. Are you telling me the truth?
Yes.
3,000 push-ups.
Yes.
That's all I'm going to say. 4,000. 4,000.
Something entirely different. No,
By the way, I'm glad you said that. By the way, if you forget the plus C at this point, that's a common thing. If you forget the plus C at this point, as far as points, you would get the separation. You would get the integrating that side. You would get the integrating this side, but then because you don't have the plus C, you would lose the integrating that side, and you're not eligible for anything else. So you would max out at 2 out of the 5 points, just so you know. Question?
That's just about the next step.
All right, so let's see. We have our plus C.
Yeah, would you like be in with the negatives?
So here's what I would do. I'm glad you said that. Here's what I would do. Before I E it up, you don't want to E it up unless you have just a natural log. Like, I don't want to E it up with that negative. So why don't I multiply through by a negative to get rid of that first? And so I have the natural log of 1 minus y equals positive cosine. Do I have to write minus C? Plus C minus C, it's still just C, right? If you write minus C, it's okay as long as you keep it all the way through, all right? So I'll just leave the plus C. Now I would say let's E it up. And by the way, when you go to college, don't use that phrase, E it up. Do it because it's nice, but don't use that phrase. And if you do, don't tell them my name. It's easy to know what you're doing when you say that, okay? That's like people who say butterfly method. Oh, it just eats all over me.
Yeah, I don't like that.
I also don't like people who say SOHCAHTOA, but we already had that conversation.
That's
It is for me, it's a good way to remember it. Like
That made me remember it so easily.
like PEMDAS.
Here's the thing. I get you. I hear you, and I'm good with that. But most people who say, oh, yeah, SOHCAHTOA, I'm like, okay, what does that mean? Yeah, I forgot. I just know it's there. And they usually put them in the wrong order. Well, yeah, I'm just saying. Okay. What's the cosine of 0? It's not 0, it's 1, isn't it?
It's close.
Oops. And you might be thinking, oh, C is a fraction. Who cares? Just plug it in. Doesn't matter how ugly it is when you plug it in. Listening. Do we agree, first of all, on solving for C?
Yes.
Everybody's okay with the 1 over negative E or negative 1 over E? When I went to plug it back in, I noticed that because of the minus in front of the C and then the negative, that's why I turned it into a plus. Are we okay there?
Yes.
And so it's fine. I put the 1 over E in place of the C out in front, and then I have E to the cosine. It's perfectly fine on a free response to leave it like that. Everybody with me? But I do want to show you something. If this had been multiple choice, and you certainly do not have to do this on free response, but if this had been multiple choice, they probably would simplify this to be 1 plus E to the cosine x minus 1. Because isn't this the same as E to the negative 1 times E to the cosine x? If they're being multiplied, you can combine them into one thing. Again, I'm not saying you would have to do that, but I want to point it out to you to recognize it in case you ever need to recognize it. This plus that I haven't read. So originally there was a minus here, but then C was a negative.
Right.
So that's where it became a plus. And if I were you, don't try to be fancy on free response. Leave it ugly. Doesn't matter. How are we doing? Is everybody okay with that? So the last thing I want to show you then is that last example. It's a lot more generic. These are all nice and neat. They're satisfying because you can get all numbers and everything. But I want to show you this last example. Write and solve. So 2 things. The differential equation. Okay, hold on. How do you write a differential equation? That means write a derivative equation. Okay, so write a derivative equation and then solve it that models this verbal statement. Okay, the rate of change of r with respect to t. How do I write that phrase? dr dt, rate of change of r with respect to t, is, what goes in place of is? Equals proportional to. What does proportional to mean? It means times a constant. Times a constant. So I'm going to say a constant, but I don't want to use C only because I know when I integrate I'm going to have a plus C, and this is a different one. So how about if I use K for constant? Okay, so equals K times, that means is proportional to, square root of R. Okay, so I've written my differential equation, and now it's saying to solve. So in this case, I'm not going to be able to find my plus C because I don't have an ordered pair, but you might be thinking, well, do you really have to separate? Because k is a constant. Yeah, but there are two variables here. What are the two variables? R and t. So you still have to separate your r's and your t's. So if I move the square root of r to the left, it's going to be 1 over the square root of r dr. Everybody okay with that? Equals, now, what about the k? Does it matter which side I put the k on if it's a constant? It does not matter. If I were you, I would leave it over on the t side. Okay, but it does not matter. So I'll leave the k, and then I have a dt. Okay, everybody okay with my separation? Logan? You good? Okay. How do I integrate 1 over square root of r? Do I do natural log of the square root of r? No! Think of it as r to the negative 1/2. I bet if you write it like that, you would know how to integrate it. Because anytime I just do a power of x, isn't it just x to the n plus 1 over n plus 1? So it's going to become r to the what? 1/2. And instead of saying over 1/2, we'll say times 2. It's not that I don't think you know how to integrate that. It's just that you get so caught up in the idea of natural log, you think everything that's a fraction is a natural log. And it's not. Equals, how do I integrate k?
K squared over 2.
Well, k is not the variable. It's just a constant.
So it'd be K.
So it'd be kt. Right, good? Well, what if it were a 2? How would you integrate 2? Wouldn't it just be 2t? And since k is a constant, it's just going to be kt. Right, I said to leave it. You don't. It doesn't matter, but
So the integral of dt would just be t?
yes, because it's kind of like integrating dt is like 1 dt, and it would just be t.
And why doesn't like an extra r pop out from integrating the dr?
We're not doing the derivative. Remember, if I integrate any power of x, it just becomes x to the n plus 1 over n plus 1. So if I integrate any power of r, it just becomes r to the n plus 1 over n plus 1.
So you aren't integrating the dr.
So
That's just the notation.
that's just the notation thing, yeah.
Except for x to the negative 1.
Pardon me?
Except for x to the negative 1.
Yes. Well, it's still just the notation. You always have to have the d what...
I meant the n plus 1 thing.
Yes, 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 yes.
So when is dy dx just notation versus something new?
It really is. So it's always both. It's just the way people are looking at it. So if I have, let's say I'm integrating dy dx, right? What you're not thinking about, let me back up. Let's just say I have dy dx equals 1. If you think about, if you say, hey, I'm going to integrate dy dx, I get y. If I integrate 1, I get x and then plus c, right? What you're not thinking about is really what you did in doing this is really you said, hey, I need to move the dx over here. And then when I integrate both sides, this is like integrating a 1 dy, which would give me a y, and integrating a 1 gives me an x over here. So this is just telling me what the variable is in terms of. So where we always say dy dx, that's like saying it's in terms of x, but we always assume it's in terms of x unless we're told otherwise. So it's kind of all the same thing. It's just that, again, it wasn't like we needed to know that yet because everything was x. Now we need to know because everything is not x. Okay? And then one last step here, we need to solve for r, right? Because when it says solve the differential equation, that means find r. So r is going to be half of that stuff. And then what? Squared. And again, you can distribute the 1/2 to the c or not, since it's just a plus c.
Would you keep all of that, like the square of the whole thing.
Yeah, because you, again, just like square roots, you can't square each one separately. Like if I have x plus 3 squared, I cannot say x squared plus 9. I can't do them separately, so you just leave it as the whole thing. Okay? Feel like you got the idea? What's going on? There you are. So your homework is the 6.1. And next class, we do slope fields.
When's this class end?
Huh?
When's this class end?
10 after.
Oh, so. Right now.
Right in 1 minute. Everybody say goodbye to Matthew.
Bye,
Bye, Matthew.